Welcome to Switzer.com. Here in this video we're going to discuss about the enthalpy of reaction, enthalpy of formation and enthalpy of combustion. These are the three things that we will discuss here in this lecture. We know when reactants combine and they form the products, either the heat is given out or it's taken in. Depends whether the reaction is exothermic or endothermic. So when all the reactants, as we find in a balanced chemical equation, when all these reactants combine and they form the product, the energy change that occurs there is what we call as an enthalpy of a reaction or the reaction enthalpy. Alright, so here in this reaction we find that 1 mole of an ethanol reacts with the 3 moles of oxygen and forms 2 moles of carbon dioxide, 3 moles of water. So when all these reactants combine, as we find in a balanced chemical equation, when all these reactants combine and the energy change which occurs there is what we call as the enthalpy of a reaction. So that means for this one, the enthalpy of reaction is 1367 kilojoules, right? This is the amount of energy that has been released. Negative here indicates it has been released. That means this is an exothermic reaction. Now what's enthalpy of formation? Enthalpy of formation means the energy change which occurs when 1 mole of a compound is formed from its constituent elements under their standard conditions, right? Suppose here we have a methane. So enthalpy of formation of a methane means how much energy change occurs when 1 mole of this methane is formed from the carbon and hydrogen, right? And here we find that the enthalpy of formation is negative 74.81 kilojoules. That means this is the amount of energy that has been released when 1 mole of methane is formed from the carbon and the hydrogen, from the constituent elements. Alright, so here the enthalpy of the formation of water is 285.8 kilojoules per mole, right? That is the enthalpy of formation of water, because that is the heat change which occurs when 1 mole of 1 mole of water is formed from the hydrogen and the oxygen. Here we got a reaction. Hydrogen and the bromine in the elemental form, when they combine, they form the hydrogen bromide. And the enthalpy of a reaction here is 72.8. Right? So this is the energy change which occurs when 1 mole of hydrogen reacts and with the 1 mole of bromine and they form 2 moles of hydrogen bromide. So that means this is the enthalpy of a reaction. Alright. But what will be the enthalpy of formation of HBr? As per definition, we know that enthalpy of formation means the energy change which occurs when 1 mole of hydrogen bromide is formed. Correct? So here this is the energy change for the 2 moles, right? For the 2 moles. When 2 moles of HBr are formed from hydrogen and bromine, the energy change is 72.8 kilojoules. And then what will be the enthalpy of formation? So that means if you want to find out the enthalpy of formation of HBr, that will be 72.8 divided by the number of moles that are formed here, that is 2. So it will be negative 72.8 upon 2, that will be 36.4 kilojoules, right? Negative 36. That means enthalpy of formation of HBr is not 72.8, rather that is the enthalpy of a reaction. Alright. Enthalpy of formation of HBr will be 36.4 kilojoules. Let me take another example to make it clear. Suppose we have here a reaction between nitrogen and the hydrogen and they form ammonia. When it forms ammonia NH3, and when I balance it, it is 2 moles of ammonia which is formed from 1 mole of a nitrogen and 3 moles of hydrogen. And enthalpy of a reaction here is it's negative 92.2 kilojoules. That means when 1 mole of nitrogen reacts with 3 moles of hydrogen, they form 2 moles of ammonia and the energy change is 92.2 kilojoules. So this is the enthalpy of formation of ammonia? No, it's not. Correct? Why it's not? Because we have here 2 moles of ammonia. This is the enthalpy of a reaction. As per definition, we have mentioned that enthalpy of reaction means the energy change when all the reactants combine and form the products. Correct? So in the product you can have a 1 mole or may not be 1 mole, it may be 2, 3, whatever it is. Right? Enthalpy of a reaction did not involve the formation of 1 mole of substance, right? But enthalpy of formation is always for 1 mole. Okay, that means here this 92.2 kilojoules of heat is released when 2 moles of ammonia is formed from the constituent elements. So the enthalpy of formation for ammonia for 1 mole will be half of this, that will be negative 46.1 kilojoules. That means the enthalpy of formation of ammonia is 46.1 kilojoules. Now what about the enthalpy of combustion? We know combustion is when a substance reacts with an excess of atmospheric oxygen, right, and forms the different types of oxides. So here we got the methane, it reacts with oxygen and forms the carbon dioxide and the water. So that is the enthalpy of combustion of the methane, right? Enthalpy of combustion means the heat change, right? It is the heat change which occurs when 1 mole of a substance, 1 mole of substance, here is the methane, right, that reacts with the oxygen, with a sufficient amount of oxygen. So 1 mole of a methane when reacts with atmospheric oxygen, the energy change which occurs there is what we call as the enthalpy of combustion. So enthalpy of combustion for methane is 890 kilojoules. That means 890 kilojoules of heat is released when 1 mole of a methane reacts with the atmospheric oxygen and forms the carbon dioxide and the water here. Here is another reaction. This one we have just learned about this one. This is the enthalpy of formation of water, because water is being formed from the hydrogen and the oxygen. Okay, and I can call this reaction as the enthalpy of combustion as well, because here the hydrogen is the fuel that reacts with the atmospheric oxygen and forms the water. And when 1 mole of hydrogen reacts with the oxygen and forms water, so you can say that this is also the enthalpy of, this is not only the enthalpy of formation of water, this is also the enthalpy of combustion of hydrogen. Alright, this is the enthalpy of combustion of the hydrogen as well. So this reaction here, the energy change is given 285.8, that is the enthalpy of this reaction. That is also the enthalpy of formation of water. That's also the enthalpy of combustion of hydrogen. Another example here, we got the carbon reacts with oxygen, forms the carbon dioxide, and the energy change in this reaction is 393.5 kilojoules. That means when 1 mole of a carbon reacts with the oxygen and forms carbon dioxide, this is also a combustion, right? Because here the carbon reacts with oxygen and forms carbon dioxide, and a lot of energy is released there. So this is the enthalpy of combustion of carbon. And I can say it's also the enthalpy of, I can call it as the enthalpy of formation of carbon dioxide also, right? It's also the enthalpy of formation of carbon dioxide. This is also the enthalpy of a reaction as well. This is enthalpy of formation, right? And it's also the enthalpy of combustion. Enthalpy of combustion of what? Carbon, right? Is the enthalpy of combustion of the carbon. 393.5 is the enthalpy of combustion of carbon. It's also the enthalpy of formation of carbon dioxide. It's also the enthalpy of a reaction. Hope you got the concept. Thanks for watching the video. Bye for now.